In the given problem here, see, in the given problem, in the given figure, AB and CD are two parallel chords, right? And of a circle with radius, with center O and radius 5 centimeter, such that AB is equal to 6 centimeter and CD is equal to 8 centimeter, and OP is perpendicular to AB. OP is perpendicular to AB and OQ is perpendicular to CD, right? Now we have to find out the length of this PQ, okay? So in order to do that, first we have to find out OP is equal to what, correct? We have to find out OQ is equal to what, correct? Then what you can do is OP minus OQ will be equal to PQ, right? So that is where the problem lies, correct? Now let's see how to go about it. Now here let us run down the data. One, we know AP is equal to half of AB. Yeah, I know you got a question. We'll solve it. Have a look. That means half into AB is 6 centimeter, 3. Correct? Also, number 2, we know CQ is equal to half of CD, that is equal to half times 8 centimeter. So 4 centimeter, correct? Right? Now we'll join OC and OA, correct? Now you got two right angle triangles, OPA and OQC, right? Now applying Pythagoras theorem, in triangle OPA, right? We get OA square is equal to OP square plus AP square, correct? So we put in the values, plug in the values. So 5 square is equal to OP square plus AP we have found out to be 3 square, right? So we get OP square is equal to 25 minus 9, 16, right? So you can write OP is equal to 4, plus minus 4. So we'll take up plus 4 because it's a length. Similarly, if we apply Pythagoras theorem, similarly, in triangle OQC, correct, we get OC square is equal to OQ square plus CQ square, right? So OC square is 5 square plus OQ square is unknown plus CQ square is we have found out to be 4 square, right? So we get 25 minus 16 is equal to OQ square. So we can conclude OQ is equal to 3, right? So now we have found out OP. We'll write down here. OP is equal to 4. correct? OQ is equal to 3, right? So OP minus is equal to 4 minus 3 is equal to 1. So therefore, PQ is equal to 1 centimeter. Okay, the questions I will answer. The questions would be, how you know that AP is half of AB, and similarly CQ is half of CD, right? I get your point. Hello everybody, welcome back to Have Fun and Learn. I'm JP Datta, your host. Yeah, we'll have solution to all those whys, and believe me, solving NCERT, solving RS Agarwal, solving R.D. Sharma really doesn't guarantee you 90% plus marks in boards. What guarantees you marks is understanding the dynamics behind all these problems. So I try my best to get to the bottom of what goes on, what is the dynamics behind these problems, and let us see how we solve the whys that you had in the last example I solved, right? Now see theorem number 1. A perpendicular dropped from the center on a chord divides it into two equal parts. This particular theorem we used in the last problem. Now see how we prove it. Do you remember congruency of triangles? That we had a number of classes on that. We used congruency of triangles to prove it, right? Have a look. So we join these, right? AO and OB, correct? Now see, so this is M, right? In triangle OAM and triangle OBM, correct? Number 1, OM is equal to OM, common to both, right? OA is equal to OB, radius and hypotenuse. Correct? And angle OMA is equal to angle OMB is equal to 90 degree, right? So therefore, triangle OAM is congruent to triangle OBM, right? This is B, correct? Understood? So if that is so, in that case, we can write AM is equal to MB CPCT. Correct? So that proves that a perpendicular dropped from the center on the chord divides into two equal parts. So that is this theorem we used in the previous one. By the way, as I said, you are with HaveFun&Learn, and I am JP Datta. Yes, please subscribe, comment, and share. That will inspire me, and of course, you'll get notifications on videos I upload in YouTube as and when. Equal chords are equidistant from the center. Let's see how we can prove that. We join, so AB and C. AB is equal to CD, two equal chords of a circle with center. All right. Again, we will use congruency of triangles, right? So we'll join CO. Correct. Now see, in triangle ONC, which is right angled at N, because ON is perpendicular, ON is perpendicular to CD, and triangle OMA, right angled at M, OM is perpendicular to AB, right? In these two triangles, number one, OC is equal to OA, radius, as well as the hypotenuse, correct? As well as the hypotenuse. Number two, CN is equal to AM, right? Chords bisected, correct? And three, angle ONC is equal to angle OMA is equal to 90 degree, right? So therefore, triangle ONC is congruent to triangle OMA. So by what rule? Right hypotenuse side, correct? So from here we can write ON is equal to OM. So we can see that equal chords are equidistant from the center. So we'll pick up a few more theorems in the next class. Until then, bye-bye. And also, we will pick up some problems also, not only theorems, we'll solve problems also in the coming classes. Till then, bye-bye.